Okay, we're gonna begin our notes for what if the inequality has two variables. That means that today, according to the learning goal, we will learn how to graph linear inequalities with two variables. So let's begin with step 1. And in step 1, I'm gonna give you an example of an equation. Let's write y minus 1 is greater than x. So we're gonna start by justifying in the last column. The first step is always going to be to always start by isolating the variable y on the left side. Of the inequality. So again, always start by isolating the variable y on the left side of the inequality. The left side means this side. This is the left side of the inequality. That means that according to this step, I have to leave y by itself. So that means I have to move this -1 to the other side. So I'm gonna do that like I normally do with an equal. When we have equal signs, I'm going to add 1 to both sides. Again, I'm adding 1 because that way this can cancel. And now I have y is greater than x plus 1. And now the y is isolated, so I'm done with step 1. Sometimes it's already going to be isolated like that. So you can skip this step, but we always start by doing, by isolating the y. So now we're ready for step 2. In step 2, we're going to change the inequality to an equality. That means to an equal sign. To an equality symbol. And in parentheses, I'm going to say for now because it's only going to be for this step. So I'm going to go ahead and take my equation y is greater than x plus 1. And I'm going to change it into an equal sign. The reason I'm doing that is so that I can see or I can look at something that I already know. This equation is written in y equals mx plus b. Remember that m is our slope, b is our y-intercept. That means that this number right here is our y-intercept. And the number in front of x, which is 1, is going to be our slope. Okay? So that's the reason why we're putting it into an equal sign. So let's go to step 3. Step 3 is going to be to graph the boundary line from step 2 in the coordinate plane. Remember, the less than and the greater than, we're going to use a dashed line because remember, those were open circle. When we graph it in a coordinate plane, they're going to be a dashed line because it doesn't equal the dashed line in this case. And when we have the equal, the less than or equal, and the greater than or equal, we're going to use a solid line. Okay. The boundary line that we're talking about here is going to be the equation that we got in step 2, which is y equals x plus 1. So let's go ahead and graph y equals x plus 1. Okay. This is going to be 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm labeling it. Okay, so remember our y-intercept is at 1. Let me use a different color. And our slope is 1. That means we're gonna go 1 up and 1 to the right. And we have a dashed line because we have y is greater than x plus 1. Again, this means that it's going to be a dashed line. So I'm going to go ahead and draw my dashed line going through those points. And I'm going to draw arrows at the end, okay? That's it. That's step 3. We're graphing. We're doing a dashed line again because we have a greater than. And we just grabbed our boundary line. So let's go to step 3. Sorry, step 4. So in step 4, we're going to shade one side of the boundary line I'm sorry, I got interrupted and I had to stop recording. But let's continue with step 4. We're going to shade one side of the boundary line by substituting a point. Oh, that doesn't fit. But it should say substituting a point. Okay. What this means is because, how do I explain it? Remember that we're talking about an inequality. So because we're talking about an inequality, it's including more numbers than just this line. It's either going to include all these numbers in this side or it's going to include all the points that are on this side. To figure out what side I should shade, I need to check using a point. The easiest point to check would be 0, 0, which is right here. And if I substitute 0, 0 in this equation and it turns out true, that means that this side is shaded. If I substitute 0, 0 and it's not true, then the other side is the one that is shaded. Let me show you. So I'm going to choose 0, 0. Oh, I'm sorry. 0, 0 to substitute in my equation y is greater than x plus 1. So I'm going to, and remember this is y, this is x. So 0 is greater than 0 plus 1. 0 plus 1 is just 1. And 0 is greater than 1. Is this true? No, right? 0 is not greater than 1. That means it's not true. That means that this side where the 0, 0 is at, it's not going to be shaded. We're going to shade the other side of the boundary line because again this right here is not true, which means that it's not including this point right here. It's including the other side. Let me show you another quick example so that it makes sense. We're not gonna write all the steps again. We're just gonna try to follow them. So let's go ahead and use an example 2. And we're going to have y is greater than or equal to 2x minus 5. So remember, step 1 was to isolate y, which is already isolated. Step 2 is to, for now, make it an equal sign so that we can see that this is the slope right here. And negative 5 is going to be our y-intercept. Step 3 is to graph my boundary line. I'm going to make this 1, 2, 3, 4, 5, and they're negatives because they're under the line. And this is going to be 1, 2, 3, 4. Okay, let's plot. Remember, we start with our y-intercept, which is -5. And then I'm going to go 2 up and 1 to the right. Now, in this case, we have a greater than or equal, which means we're not going to use a dashed line. We're going to use a solid line. Okay. And now we need to check if we're going to shade the side where we have 0, 0. Remember, this side is 0, 0. Or the other side. So let's substitute 0, 0 into our equation. Y is greater than or equal to 2x minus 5. Sorry, I keep saying equation, but I should say inequality. So let's substitute. We're going to have 0 is greater than or equal to 2 times 0 minus 5. 2 times 0 is 0 minus 5. And then we have 0 minus 5 is -5. Is this true? Is 0 greater than -5? And I believe it is true, right? That means that we're going to shade wherever the point 0, 0 belongs to. So that's right here. So I'm going to shade all this side because that means it does include the 0, 0. And we're done.